Okay, so after a couple minutes, do you guys like see any that you had questions about and you wanted to talk about? You have one?
31.
31. Okay. So the answer to 31 was C. Yeah, okay. So it's about the Australian English. And the question 31 says, which of the following alternatives to the underlined portion is least acceptable? So your options were A, rhythm, B, sound, C, shout, and D, cadence. In the text, they use lilt, so it's kind of like describing the Australian English. So we think that our answer choices should also describe the Australian English. If you look at A, rhythm, that kind of describes like maybe the pace of the English, like how they were speaking. B, sound, that's also like describing the English. And then for C, shout, I guess this one's a little bit confusing, but the reason that they said is that shout is incorrect because it doesn't fit the context of the sentence as well as the other three. And they're not necessarily shouting when they speak the English, so that's why that one would be the least acceptable, that option. Okay, any other questions?
40.
40. Okay, 40's in that same passage, and the answer was G for that one. Let's see, so okay, let me look in the back of the book for their explanation. So they said that the answer was G because therefore suggests a casual relationship. And that the reason that the majority of Australians reject that form of dialect is because they think it's too haughty and snobbish. If I'm looking at it, so I remember like a couple weeks ago we were talking about the famous like adverbs, and we talked about therefore. I said when we talk about that one, we should always think like cause and effect. So in the passage, although it can kind of not seem like it, they're saying that Australian English varies from one region to another, and then as an effect, a bathing suit can be called a swimmer or it can be called a tog, and then in other areas, it can be referred to as a bather. For that one, I can also see why F would work, saying for example, but they said that the best answer was G to say therefore. Okay, any other questions? Anyone else have questions? No? Okay. So we don't have any more questions about the test, and we'll get started on our topic for today. So we're going to be doing math. So you can put away your ACT books, and then take out your notebooks, and then hopefully you all have a calculator with you, but we won't use it that much. Okay, so today we're going to be talking about matrices, which are like, if you've seen them, you probably might have seen them before. They're like little boxes and they have numbers in them. They usually pop up like at least once on an ACT test. I've always seen them like maybe one time or none at all. So if you're not like exactly strong on how to do them, it's okay because you'll only maybe miss like one question. But yeah, so they'll pop up like maybe once or none on an ACT math test. Okay, so first let me define them. Oh yeah, and then also if you have your math packets with like the fireworks on the front, these ones, it's on page 12 I think, and that kind of defines matrices, and then we are going to be adding, subtracting, multiplying, and then finding the determinant of them today. So that's all detailed on page 12 of your math packet. Okay, so the definition for a matrix, matrix is just singular, and then matrices is like plural. A matrix is a rectangular arrangement of real numbers. And then again, if you look at your math packet, page 12, you can see one on at the top there. And like I kind of said, it's like a box with numbers in it. And then on your packet, it says made up of rows and columns. So when we're talking about matrices, we like talk about them in rows and columns. And then lastly, okay, so like I said, we talk about matrices in rows and columns. And then the dimensions of a matrix, we call that the order. So real quick, we're going to be like, after this, we'll be defining order, and then we'll start doing some math with matrices. Okay, so the order of matrices, like I said, it's like we talk about the rows and the columns. So if I had a matrix with just one number in it, my brackets, and then the number 2, it has, my rows go this way, so we start talking about rows first. It has one row, and then vertically are the columns. It has one column, so it'd be a 1 by 1 matrix for this example. Okay, I got my second one here. So don't look at this part. But this second matrix, it has one row going across, and then it has 1, 2, 3, 4 columns. So this would be a 1 by 4 matrix. So every time we're talking about matrices, the order is the rows by the columns. So always rows first and then columns second. Okay, does everyone have the notes down? Oh, sorry. Does everyone have the notes down? Yeah. Okay. So here's our first kind of like rule. But two matrices are equal when their corresponding entries are equal. So we're going to do one, you might actually see one like this on the ACT. We're going to do a practice one. But I'll show you what I mean with an example. Okay. So here I've got two matrices, and if we look at their corresponding entries, we look at like the top left-hand corner, it's 16 and 16, 4 and 4, and then it goes 5 and 2x. Okay, well those are different, but if we look at the rest, Goes 4 and 4 again, -3, -3, 13 and 13. So that tells us that these matrices are equal to each other. They just got variables thrown in. So what we can do here is actually solve for x and y because we know these two matrices should be equal to each other. So we have a 5 here and then a 2x there. Well, we know that the matrices are equal, so we can write an equation. So if I were to solve for x, I'd write 2x plus 1 is equal to 5. And then get x alone, so I'd subtract my 1. 2x is equal to 4. Divide by 2, and then my x equals 2. So that's how I would solve for x. If you also see on the far right over there in the middle, we have a 3x, and then over here on this matrix, we have a 6. So we can also check our math, like solve for x again, and set 3x equal to 6. I'm not going to write that, but if you solve it, you get x equals 2 again. And then lastly, down here at the bottom, we have 3y minus 5, and that should be equal to 4. So do you guys want to solve for y real quick on your own? Okay, does someone want to like call out what they got for y?
3.
Yep, y should be equal to 3. Okay. Okay, so now we're going to add matrices. So rule with that. Okay, so to add or subtract matrices, they have to be the same order. And then remember we talked about order being like the rows by the columns, so they need to be the same. So my first matrix is 2 by 2. The second one also has to be to add or subtract them. So let's just start off with a couple of examples. Okay, so I've got my two matrices here, and they have the same order. I can check. First one has 2 rows, 2 columns, and then the second one has 2 rows, 2 columns. So to add them, you just like add the corresponding numbers. So I'm gonna add my top left ones first. So I'd add -1 and 1 together. That would be equal to 0. So I put that in the same spot where both of those numbers were. 2 and 3 I'll add together to get 5. 0 and -1 I'll add to get -1. And then 1 and 2 I'll add to get 3. So that would be the answer if I were to add those two matrices. Okay. So I'm going to have you guys do this next one on your own, and it'll be a subtraction one, but it's the same principles. Instead of adding, we're just going to subtract. Okay, so subtract those two, and then we'll go over the answer. Okay, so I'll start writing the answer. Okay, so hopefully y'all can see that. Does anyone have any questions about how we got here? No? Okay. So that's basically it for adding and subtracting them. Now we're going to talk about multiplying. So first thing we're going to talk about is scalar multiplication. So that's when we have a matrix and then we'll put like a constant in front of it. So I'll show you what I mean. But I'm actually going to write two matrices up here. Okay, so here's my matrix A, and then over there is my matrix B. So to start off, we're going to find 4A. So this is what I'm talking about when I said scalar multiplication. We put a constant in front of like our matrix. So this one's pretty simple. It's what we're just going to do is multiply 4 to every single number inside our matrix. So to start, I do 4 times 4 is 16. And then you can go either way you want. I'll just go vertically. So 4 times 0, 0. And then 4 times negative 3 is negative 12. Then I'll do my next column. So 4 times negative 1 is negative 4. 4 times 4 is 16. And then 4 times 8 is 32. So that's using scalar multiplication to find our matrices. And that would be the answer for A is 16, 0, negative 12, negative 12, 16, 32. Okay, so for my next one, I'm going to have you guys try it. Using the same matrices A and B, I'm going to have you find 3A minus 2B. So you're going to have to do 3 times everything in A, and then subtract 2 times everything in B. Okay, I'm going to start writing the answer up here. So first, I'll break up my 3A and then 2B, and then I'll subtract them. Okay, so here's 3A, 3 times everything in A, and then 2B. Then I subtracted those two, and I got my answer. So does anyone have any questions about how we got there? Does anyone have any questions so far? No? Okay, so that was the scalar multiplication, and then next we're gonna just multiply them together. So there's a couple rules with that we're going to talk about. Okay. So when we're multiplying matrices, I'm going to have you think of this one rule. Left. So it's left, across, right, down, and then you can also think of it with the first letter of each as like lard. So that's what I'm going to have you think of this acronym when we're multiplying two matrices together. And then before we start, one rule. Okay, so rule when we're multiplying matrices is that the number of columns in the first matrix has to be equal to the number of rows in the second one. And so if that isn't true, then your multiplication will not work. So our first example, we're going to multiply A and B, and then before we start, I'm going to check the order of both. So this first one has 3 rows and 2 columns. All right, 3 by 2 at the bottom. And then my second one has 2 rows and 2 columns. So 2 by 2. So although they don't have the same order, the number of columns in this first one is 2, and then the number of rows in my second one is 2. So that tells us that we can multiply those two together. Okay, so I'll erase that. And then we are actually going to multiply them. We're going to find AB, so A would come first. Okay, so hopefully you can see all my work. I should have wrote this stuff smaller. But we're going to do our lard method, which is left, across, right, down. So to start off with, we're going to do the left column, and then we're going to go across. So I'm going to do -1 times -3. And then we're not done yet. We also have to do -1 times -4. Okay. Then my second number that's on the left is 4. So I'm going to do 4 times -3. That's me going across. 4, -3. And then also 4 times -4. Okay, you guys still following? Yeah. Okay. And then lastly, I'm going to do 5 times -3. Plus my 5 times -4. Okay, so that was me going like left across. And then on my right column, I'm going to go downwards. So these are all like the first three numbers in my matrix, and I'm going to go to the second column. So here I'm going to do 3 times 2. Oh, sorry. Oh, wait, no, not 3 times 2. I'm going to do negative 1 times 2. So when I do the right ones, I'm going downwards. And I'm going to add it to negative 1 times 1. So when I did like the left column on here, I went across, and then when I'm doing the right column, and go down, if that makes sense. Okay, so I did negative 1 times 2, and then I did, oh my gosh, okay. Sorry guys, back up. Okay, we're gonna start over on the right column. So I did negative 1 times 2, that was correct, so I went to the right. And then I'm going to do 3 times. Okay, sorry guys. Sorry if I'm confusing you. I don't want to. But what I mean when we go right is that when we go down this way, we go right on our first one. So I went from negative 1 to 2. I multiplied those together, and then I moved to the right. I do 3 times 1, so I went down. That makes sense? So I'm going to do plus 3 times 1, and then I'll show you on the next one. But I'm going to do 4 times 2. And then I'll do negative 2 times 1. So I'm moving down. And then for my bottom one, I'm going to do 5 times 2. Plus 0 times 1. Okay, so that should be my entire matrix. Hopefully you can see that. And then we're just going to like combine those, like multiply those together and add them. So I'll write what your answer should be. If we did like negative 3 times negative 1 is 3, and then plus okay, so I think, oh my gosh, I'm so sorry guys. I think I wrote wrong numbers down. So this whole entire thing is incorrect. I was like looking at it, and whatever on the board does not match up with my notes. So sorry about that. Do you guys want to like erase, not the matrices, but erase the math, because that is not correct. And I don't know why I messed up, but just erase that whole thing and we'll start over. So sorry about that. Okay, let me look at this again. so I figured it out. Sorry about that. Why I made the mistake. But we're going to do this again. So the same two matrices, A and B, and then we're going to multiply. So we're going to do, hopefully, okay, so like disregard everything I said before, and I hope I didn't confuse you. But we're going to like start over. So we're still going to do our left across, right down rule. But hopefully I can explain it better this time. So in my first row, first column, it's going to be -1. Okay, so it would be -1 times -3, and then plus 3 times -4. So when I'm doing my okay, yeah, so when I'm finding the numbers that go in my left column, I'm going to multiply across. So across meaning going like this way. So I do my -1 times -3, and then I do 3 times -4. So that's what I mean by across. So I'll show you in the second one. It should go 4 times -3, and then because we're going across, I'll do -2 times -4. And then the third one down here, is 5 times -3, and then across 0 times -4. So that would be my first column. And then my next column, I'm going to go, because I'm doing the right, we're going to multiply like downwards. So I do -1 times 2, and then I'll do 3 times 1. So we move down. Before we moved across, and now we're moving down. So then I'll do so my second one is 4 times 2, and then -2 times 1, moving down. And then 5 times 2, 0 times 1. So that should be the correct matrix. And then if we combine like terms, or not combine like terms, if we multiply everything together and add them, you should get okay, you should get -9, and then if you go down -4, -15, 1, 6, and 10. So that should be the correct answer. And then the new order of your answer should be, the order should be the number of rows in your first matrix by the number of columns in your second one. So this one is a 3 by 2. Okay. So I'm really sorry if that was confusing, but luckily we can use our calculators to find the answer. So I'm gonna have you guys all grab your calculators out. And this process actually like does take like a while anyway. So when you are using, when you do see like a matrix question on the ACT, you should probably just use your calculator because it will be a lot faster. So if y'all have your calculators, what you do is you press the second button, and then if you see like that button that says like x to the -1, above it there's like a matrix in that different color. So I'm gonna have you press that button, and then you should see like a bunch of letters with brackets around them. And so to edit, we'll just use, yeah, we'll use this one for an example. My A and B. So I'm gonna, instead of just clicking it, I'm gonna move to the right over to edit. So I'll go to edit and then press enter. Then it'll like bring up a matrix like bigger. So you have to change the order to fit like the one you're talking about. So I'll do my first one. The order, it has 3 rows and then 2 columns. So I type in 3 by 2. And then press enter and then edit the numbers to like fit the matrix. So I type in -1, 3, 4, -2, 5, and 0. Okay, and then close out of that. Go back into the matrix button after typing like second, and then move over to matrix B, and I'm gonna scroll over and edit that one too. So that one is a 2 by 2 matrix. And then I'll put in my numbers to match it. So -3, 2, -4, and 1. So once you have those typed in, close out of that. And then to multiply them, it's the same button like second matrix. And then instead of like editing them, I'll just click on it. So I'll press enter for matrix A. And then go back in, select my matrix B. And then multiply them. Okay, did you guys get an answer out? Yeah, okay, I typed mine wrong into my calculator, but you should get the same one you see here. Okay, so the last thing we're going to talk about today is finding the determinant of a matrix, and then that's also like at the bottom of your math packet, if you see it there. Okay. So we're going to talk about the determinant. Alright, so every square matrix has a real number associated with it, and we call that the determinant. And then what I mean by square matrix is that it has to be like a 2 by 2 one or like a 3 by 3 one. We're just going to find a 2 by 2 one today, and then if you see any higher than that, I'd recommend using your calculator because it will take you too long, and then you're wasting time on the ACT. Okay, so if I just had like, or I guess I'll use, okay, so I'm going to write the example that's in your math packet. But if I had this matrix and then I didn't use numbers but I used like letters, to find the answer it would be A times D, so across, minus C, minus b times c. So start in the top left, go across, and then multiply the other two together and subtract them. So I'll show you guys with an example, and then we can also use our calculator to find this. So I'll show you how to do that too. Okay, so here's my matrix. And then we're going to find the determinant. So first thing we're going to do is multiply diagonally. So I do these two. So 2 times 2 is 4. And then I'm going to subtract my second 2 multiplied. So 3 times negative 3 times 1 is negative 3. So I've got 4 minus negative 3. That becomes plus 3. And then my answer is 7. So 7 is the determinant for this matrix. So I'll show you guys how to do that in your calculator. So you want to pull out your calculator again. You should already have a matrix like in box A or whatever. So I'm not going to have you type in another one, but we'll just find the determinant of that one. So it's the same like button. You're going to press second and then matrix again. But instead of scrolling over to edit, I'm just going to have you scroll over to math. So to the right one. And then at the top there, you should see like number 1, it says DET. So if you press enter, it'll bring that up on your main screen, and then go search for a matrix again. So the determinant of matrix A, I'll choose. Press enter, and then it should give you an answer. Because I typed in the wrong one, I don't think I'll have the same number as you guys, but that's how you'll find the determinant. And it's not this one, it's the one we had in our calculator from beforehand. But that's how you'll find the determinant of a matrix. And then I think that's like as far as they'll go like on the ACT with matrices. I don't think they'll ask you to do like much else. So that should cover matrices for the ACT. So do you guys have any questions at all? Hopefully I didn't confuse you that one time, but that's all we're going over today. So I guess you guys can start your break like 5 minutes early. And then if you have any other questions, you can just ask me. But that's all I have for today.